Imagine for a second the structure behind, say, your car or an airplane or even a skyscraper built with this incredible, almost absolute precision.
Precision that's really hard for humans to achieve consistently.
Exactly. And that world, it's actually already here, thanks largely to these unsung heroes of manufacturing, welding robots. Welcome to the deep dive. Today we're pulling back the curtain on these quiet revolutionary.
They really are the backbone of so much modern industry. You don't always see them, but they're absolutely critical for, product quality, safety.
And to help you get a quick but still really thorough understanding of this rapidly changing landscape, we're drawing insights from a recent market study. It's by Cognitive Market Research.
Ah, yes, their welding robot market trends and future opportunities report
Oh, good stuff.
in there.
Right. So our mission today is to unpack what these robots are, sure, but more importantly, why they're so indispensable right now. We'll look at how massive their market footprint is, what hurdles are maybe slowing down even wider adoption, and then peek into the, frankly, really exciting future that's already unfolding. AI-driven stuff.
Mhm.
The goal is for you to get a real shortcut to being well-informed on, well, a fundamental piece of global manufacturing. Okay, let's unpack this right from the start. Welding robots. It sounds a bit sci-fi, doesn't it?
Little, yeah.
But they're very real and they're fundamentally changing things. So what makes them so utterly essential for industries right now?
Well, what's fascinating, I think, is how they directly tackle multiple um, persistent pain points for manufacturers.
Hmm.
Everything from quality control
Right.
to drastically improving worker safety.
Mm.
I mean, at their core, these are sophisticated automated systems. They've got advanced sensors, precise programming, and they can execute a whole range of welding techniques. Arc welding for heavy stuff, super fast spot welding like in car factories,
Right.
or even incredibly precise laser welding for tiny electronics. And they do it all with this unmatched consistency and efficiency.
So it's not just speed.
No, not just speed. It's about doing it perfectly or very close to it every single time.
So that unwavering consistency, that repeatability, that's really what sets them apart from a human welder.
Precisely. Yeah, that consistency is just a game changer for product reliability.
And how are they actually, built? What are the components that let them do that?
They're built tough. You've got these incredibly robust multi-axis robotic arms. They mimic human dexterity, really.
Yeah.
Then specialized welding torches designed for different materials and powerful controllers managing every tiny movement with micron-level accuracy.
Wow.
Yeah, it's this robust design that ensures they can run seamlessly, continuously in an industrial setting.
And which industries are really leaning on them?
Oh, it's widespread. Automotive, aerospace, construction, electronics. They've all embraced them. They find they can significantly boost productivity, dramatically cut down on material waste, and meet those really stringent quality
Makes
standards.
sense.
And crucially, they can work effectively in hazardous environments. Think extreme heat, confined spaces,
Yeah.
places where you really wouldn't want a human worker if you can avoid it.
Right. Safety is a huge factor.
Absolutely. That alone has cemented their importance in modern manufacturing.
This sounds like, well, technology with this immense impact. And the numbers back that up, don't they?
They certainly do.
Okay, here's where it gets really interesting for me. We're talking billions of dollars, major global players. What makes specific regions or specific companies stand out in this, incredibly competitive space?
Well, if we connect this to the bigger picture, you definitely see how strategic investments and regional policies are shaping where this tech takes hold fastest. According to that Cognitive Market Research report, the global market was valued around 7.5 billion US dollars in 2024.
7.5 billion.
Okay, but here's the kicker. It's projected to almost double. They're forecasting nearly 14 billion by 2032.
Wow.
That's growing at a compound annual growth rate, a CAGR of about 8% during that period. So steady, healthy expansion.
That is robust growth. I mean, obviously automation is a trend, but what are the specific drivers pushing that kind of expansion? Is it just efficiency?
Efficiency is big, yes, but it's more than that. It's fueled by this increasing demand for automation and precision across basically all manufacturing. Plus, you've got these continuous rapid tech advancements, especially integrating AI and the Internet of Things, IoT, into the robots themselves.
So they're getting smarter.
Exactly. It's not just incremental improvement anymore. It's a fundamental shift in what they can do.
Hmm.
We're seeing innovations like ABB Robotics unveiling its IRB 760FX back in June 2023. That's not just another robot. Its design lets it handle much larger components with like unprecedented flexibility and speed. It's really
Wow.
revolutionizing automotive welding, where you have these massive parts needing quick, precise joins.
And these welding robots, they aren't just some small part of the overall robotics industry, are they? They
Yeah.
seem dominant.
Oh, far from small. They hold a truly dominant position, actually. Welding robots account for roughly 45% of the global market share in the broader robotics industry as of 2024.
45%. That's huge.
It is. It outpaces material handling robots, they're around 30%, and assembly robots at about 20%.
Huh.
And the forecast suggests their share might even nudge up to 47% by 2025. Their precision and adaptability make them a real go-to solution.
That's fascinating. So if they have such a commanding share globally, where are we seeing the most adoption? Which parts of the world? And why?
Right now, North America leads. They've got about 35% of the market share in 2024. That's largely down to early adoption and significant investment in smart manufacturing infrastructure over the years.
Okay.
Europe's close behind, around 30%, driven by their advanced manufacturing sectors, automotive, aerospace, and really stringent quality standards.
Makes
But the region that's really surging, that's Asia Pacific. While they're at about 25% share in 2024, they're expected to grow at the highest TAG around 8.5%. They're projected to hit maybe 28% share by 2025.
And what's behind that surge in Asia Pacific?
It's a few things. Accelerated industrialization, for one. Proactive government incentives pushing automation.
Government help.
Yes. And crucially, rising adoption by small and medium-sized enterprises, SMEs. They're the backbone of many economies there, and they're starting to embrace this tech.
So Asia Pacific is really catching up, partly thanks to government support and SME adoption. What about the big companies, the major players? You mentioned it's competitive. How do firms like Fanuc, Yasko, Kiki stay ahead?
It is highly competitive. And what's interesting about the market share numbers, Fanuc leads with about 18% in 2024. Yaskawa's got 15, KUK has 12.
So quite concentrated at the top.
Well, yes and no. Combined, they command less than half the market, 45% between the top three.
Oh, right. So lots of room for others.
Exactly. It suggests a dynamic landscape, ripe for specialized players or maybe disruption from newcomers. Their strategies, continuous heavy investment in R&D, plus strategic moves like mergers, acquisitions, partnerships. It's clear that staying cutting edge isn't just a goal, it's a survival imperative for them.
Okay, so we've covered the incredible growth, the global dominance, but you mentioned hurdles earlier. With all this amazing potential, what's holding the market back from even faster growth? Especially thinking about those smaller businesses you mentioned.
Yeah, and this really brings up an important question about accessibility, doesn't it?
Yeah.
How do we make sure the benefits aren't just for the giants? One of the biggest barriers, and the report highlights this clearly, is the substantial initial investment cost.
The price tag.
Right. Especially for robots loaded with the latest features, AI, machine vision, fancy sensors. That upfront cost can be a major deterrent for many SMEs. It's not just a premium, it's often a barrier to entry.
And it's not just buying the robot either, is it? There's more to the cost than that.
Exactly right.
Yeah.
The total cost of ownership, it goes way beyond the purchase price. You've got ongoing expenses, regular maintenance, software updates, the complexity of programming, and crucially, workforce training. That all adds up.
Right.
It creates this significant compounding financial burden that often puts SMEs off. They might see the long-term benefit, but the short-term cash flow just isn't there for that kind of commitment.
So money is a big one. Are there other, maybe more practical hurdles, things related to the robots themselves that make adoption tricky?
Yes, definitely. Operational complexities are a real factor. Programming and operating these advanced robots,
Yeah.
it can be quite daunting, especially for industries that don't have, deep technical expertise or experienced personnel already on staff.
So skills gap issue too.
To some extent, yes. And while there have been strides in making interfaces more user-friendly, they aren't universally accessible yet, or maybe not affordable for the smaller guys. Plus, there's an adaptability limitation. These robots excel at repetitive, standardized tasks, doing the same weld perfectly thousands of times.
That's their strength.
It is. But their efficiency can drop off in more dynamic settings. Think about jobs requiring frequent adjustments for different materials or where production demands are constantly shifting. In those cases, human adaptability might still have an edge.
Okay, so we've laid out some significant hurdles: cost, complexity, adaptability, especially for smaller players. But here's the exciting part, right? A lot of the innovation that's coming seems designed to tackle those very challenges,
That's right.
paving the way for wider adoption. So, what are the next big leaps we can expect? How are companies trying to solve those problems we just talked about?
Well, what's really fascinating here is how different technologies are converging. You've got AI, cloud computing, miniaturization.
Hmm.
It's not just making things a bit better, it's fundamentally shifting capabilities.
Hmm.
A key development, one that could really revolutionize efficiency and tackle downtime, is AI-powered predictive maintenance.
Predictive maintenance. So, knowing when it might break before it breaks.
Exactly. Take FANUC Corporation's field system that stands for Fanuc Intelligent Edge Link and Drive. It's a cloud platform using AI to monitor robot performance in real time. It doesn't just log data. The AI predicts potential failures before they happen and gives actionable maintenance insights. You know, check this bearing soon.
Huh.
It drastically cuts costly downtime.
Like the robots are learning to ask for a checkup. That's incredible.
It really is.
What else is coming that could make them more accessible, maybe cheaper or easier to use?
Well, we're seeing a big trend towards miniaturization of components.
Yeah.
That leads to smaller, more portable welding robots.
Ah, so not just huge factory installations.
Right. This could really broaden their reach, especially for use in remote sites or maybe tight, constrained environments where the big static systems just won't fit. And then there's cloud-based robotic programming platforms. These are genuinely streamlining deployment.
How so?
They allow for remote control and programming that significantly cuts down implementation time and costs, making automation much more accessible potentially for a wider range of businesses.
So even a smaller shop could potentially tap into this without needing massive on-site infrastructure or like a dedicated team of robot engineers. That could really democratize the tech.
That's the idea, precisely. And collaboration across industries is speeding things up too. Look at QKAG partnering with NVIDIA. They're integrating NVIDIA's AI tech for better vision and control systems in their robots.
Powerful combination.
Absolutely. These partnerships are vital for pushing the boundaries quickly with AI, machine learning, computer vision, and let's not forget government incentives. Particularly in emerging economies, that support is acting as a real catalyst for adoption.
Any specific, really cutting-edge examples that give us a glimpse of this future?
Oh, definitely. Novark Technologies. They launched their spool welding robot SWR back in September 2024. This isn't just a small improvement, it's really a first-of-its-kind innovation. It uses AI, machine learning, and computer vision for fully automated pipe welding.
Fully automated pipe welding. That sounds complex.
It is. It can handle complex shapes, pipes, tees, elbows, reducers, all autonomously. That level of automation delivers just unprecedented precision and efficiency in pipe fabrication, which is a huge industry.
Wow.
So yeah, all these developments, they point towards a future where welding robots are not just faster, but smarter, more flexible, capable of handling incredibly complex tasks with more autonomy. And that means an even bigger surge in automation, efficiency, and productivity globally.
Okay, so if these are the incredible innovations coming down the pipe, how do we ensure they actually get widely adopted? Especially thinking about those cost and complexity hurdles for SMEs we talked about. What are the key strategies for broader market penetration?
Yeah, it really boils down to a few critical strategies. First, continuous innovation is just non-negotiable. Manufacturers have to prioritize developing advanced solutions, but solutions that are genuinely tailored to diverse end-user needs. It's not just about building powerful robots. It's building the right powerful robots for more specific jobs, making them fit for purpose across more sectors.
And tackling that cost barrier,
Yeah.
especially for the smaller guys. How do we bring the price down?
That's a huge focus, absolutely. Strategies there include, well, exploring economies of scale in manufacturing the robots themselves. Also, implementing innovative production methods. Think modular designs, standardized components maybe, even adopting advanced manufacturing tech like 3D printing or automated assembly in their own factories to build the robots more cheaply.
So, using automation to build the automation tools cheaper.
Kinda, yeah. The goal is driving down cost without sacrificing quality or capability, making them financially viable for a much bigger slice of the market.
And finally, making them easier to use, more versatile to get over those operational complexities, right?
Exactly. Enhancing adaptability and user-friendliness is just paramount. That means developing really intuitive interfaces, maybe drag and drop programming, offering flexible programming options that don't need a PhD in robotics, providing customizable features. The easier these robots are to slot into existing workflows, the more appealing and less daunting they become, especially for industries that haven't jumped in yet.
What an incredible deep dive this has been, seriously. We've gone from understanding well, the truly indispensable role these welding robots play right now,
Hmm.
seen the market's really robust growth, their dominant position in robotics overall, dug into the real challenges like cost and complexity that still need work,
Yeah, the hurdles are real.
and then glimpsed this incredibly smart, flexible future that's coming, driven by AI, miniaturization, the cloud.
Mhm.
It's quite something.
It is, and hopefully you now have a solid, high-level grasp of a market segment that is just fundamental to how modern manufacturing works, how things get built. It's really a testament to how automation isn't just changing specific processes, it's fundamentally reshaping entire industries on a global scale.
It really is. And it leaves us with this final thought to maybe chew on. Given these rapid advancements and this push towards accessibility, what new kinds of human robot collaboration might emerge? How will these shifts reshape what we even mean by skilled labor in manufacturing in the years ahead?